Hello everyone. Today I'm going to present the paper of on first come first serve queues with two classes of impatient customers. This is a writer of this paper. This is for homework for week 16. This is my outline. The system approach, impatient customers, and MK plus MQ models, and MG1 plus MQ model, and numerical analysis, and model as performance approximation, and conclusion. System approach. In this paper, they analyze two systems in which two classes are impatient customers according to the first policy. In this they focus on two kind board distribution of service types and patient types, because other writer they only approach to one of the distribution of service types and patient types, and they will analyze MG1 plus MQ model and MMK plus MQ model. In this paper, there are two kind of customers who meet a burden or the system, and if their waiting time and exceeds the patient time. Another customer is customer who may receive service the system if their waiting time do not exceed their patient time. This is a MG1 plus system. This figure is a single server model, and I is a impatient customer from classes, and lambda is the arrival rate of customer, and gi is the service types of customers from different classes. Exponential theta is a patient time of customers. This is MMQ plus M system. The figure is a show multi-server model, and if the service does not start before the patient time is pro, the customer leaves without service. And in this paper there are a lot of mathematical equations, and they show how to compute exactly the multi-server model and single server model. And if you want to know detail, you can check it. You can check it in this paper. I'm showing they analyze the numeric analysis of three systems. The first system and the base system. In the base system, customer in both classes are equally patient, with the mean patient time theta 1 theta 2 equal to 1.5. But in the service type they are differ in service type. And the second one is a positive system. In a positive system, the main patient time of class 1 customer is 1. At the same time, the main patient time of class 2 customer is 0.5. The third one is a negative system. In the negative system, the class 1 customer have a mean time patient 0.5, and class 2 customer have a mean patient time 1 unit. This is a figure of tree system, and we can see a lot of a result For example, figure 1 is the all customer receiving service. Figure B is the mean waiting time of all customers. Figure C is a system throughput. Figure D is average service time. Numerous for in figure A, the result is I can they show detailed information of the each figure, but in this numerous analysis, I will show you the overall uh, detail overall of the result. So figure 8, managers who do not account for differences in the distribution of customer service time and patient time across classes may produce and encourage inaccurate service level forecast. In figure B, the mean waiting time of all customers, the result is the average waiting time of all customers in the base system and the negative systems are nearly equal, even though the average waiting time of customer who receives service and the average waiting times of customer who renege it are both lower in a negative system. And the figure C, an assistant robot. In this case, manager of such systems may attempt to increase the traffic through marketing efforts in order to generate additional revenue, but may instance reduce their revenues if the customers in their system who take longer to serve are also more patient. In figure D, average service time. In this figure, the result is manager may reach false conclusions regarding their service productivity if they evaluate their servers based solely on their average service times. And then the model as a performance approximation. In this analysis, data come from the multi-class call center of a small US-based bank. The first class is comprised of general banking call like balance inquiries. The second class is calling for technical support such as password reset request. This is a figure of class 1 and class 2 of a probability or density. In this figure, we can see that class 1 callers tend to have shorter service times and shorter patient times than class 2 callers. This is the figure of US big bank caller and center. This is a simulation result of a performance comparison in a real data, MMK plus M system. This AWT is average waiting time in seconds. Percentage RS equal to percentage of caller who receive service, and AQ is average number of callers waiting in queue, and the service utilization, and the last one is the average service time of caller who receive service. And you can see that the result simulation result and data in real world is almost the same. In conclusion, in this paper, I have realized that the simulated result by using a mathematical equation are almost the same the data in real world, and perhaps some cases have a little bit difference between simulated results and real result in real data. Thank you for your attention.